Hey stats class, let's look at the next section of homework and how we can use Desmos to help us with these types of problems. So once again, I see a data set. I'm going to be told to find the regression equation. Now none of these obviously are going to be given to you. You'll have to fill in these numbers. But I'm going to just grab this, copy to clipboard. Again, when I see data like this, I'm just going to copy to clipboard, throw it into Desmos. All right, if you got something in there, just clear it out. All right, paste. So there is what I see. All right, and again, what it's going to ask you for is this equation. Okay, so mx plus b, that's a line, it's a linear regression. So I'm just going to go over here and click this button to add a regression. All right, linear regression is the default, and that's what we want. And if you scroll down, there are the parameters that I need. So there's the number in front of x. It's 0.04889747. All right, round it to 3 places. So 0.049. You can see that number rounds to 0.049. You can click this button right here and drop it down into the next line, and then round these numbers as needed. Okay, so 0.049, I'll be rounding it there. All right, and this one, same thing, 3 decimal places. So that would be a 0.74. Oh, it just wants 2, sorry, 0.7. Y-intercept to 2 places, it says. Sorry about that. All right, and then it wants to know which is the scatter plot with the graph. Now, you got to be careful here because all of these include 0 on the x-axis, 0 to 800, and ours zooms in around it, so it's not going down to 0. Okay, so I'm going to click over here on the wrench tool. Let me move this over so you can see it. There's the wrench tool, and I'm going to make this x-axis lower number change to 0. All right, and then it goes between 0 and 60 on the y-axis. I can make that happen as well by making this 0 and this 60. All right, so there is my data set, and I can see that 1 matches it. Okay, it's not going downhill, so that's why it's not B. All right, now I don't have a lot of data down below it, so this one's going downhill as well. I don't have a lot of data below the line like I'm seeing here on that one. I do have a couple points at the beginning, but not all the points, so that's why I know it's not D. All right, you can also see the y-intercept where it crosses the x-axis. I'm sorry, the y-axis is at 16, and you can see that that is this is 60. Now this is 30. This is about 15. This is 60. This is 30. This is really close to 30. So that's another reason you can tell that A is the right choice. There's lots of different ways to kind of match the graph. All right, now how do I predict values? It's so easy to predict values with Desmos. Notice what they're writing here, x equals 500. Literally type that into Desmos. On the next line available, x equals 500, and click the intersection with the regression line. And there's your estimation, 40.52. That's all you have to do to come up with these estimations. 647, change that number to 647, and there's my new estimation. All right, so regression in Desmos is very easy. All right, another way you could do it without the vertical lines is once you have this equation, you click this button, drop down here and change the y to f parentheses x, close parentheses. That's pronounced f of x, and it means the same thing as y, but it allows you to use what's called function notation to make these estimations. So for part C, I got to estimate what is y when x is 321. So instead of doing x equals 321, I can also do f of 321. Right? But that will only work, that will only give me those points if I change that y to f of x. Right? If I go back to y, it doesn't understand anymore. Right? So you got to make sure that you use that f of notation if you want to use that. But again, there is nothing at all wrong with just using the x equals and clicking on those values. All right, I do want to talk really quick about, I just did the 321, and we got a number, and you can see when you get that number, there's the 31.7, so that's going to be the 32 option there. But you see the choice is not meaningful. And the reason is because with these other choices, the 500, the 647 numbers, let me just show you when I change this to 500, we are within the smallest x and the largest X. And so for all of those other choices, we were within that data. We were inside of that data. But for this one down here, the one that was 321, you can see we're not. We're over here beyond the data. So the way this works is when you do regression, your line, if it's a good fit line, and this is, R is 0.9, R squared is also a good measure of how well it fits. That's 0.82. That's kind of like a grade on a test. Like you made it 83 on a test. That wouldn't be a bad grade. This is not a bad model. It's about an 83%. It explains the line explains 83% of the variability in the Y's that we're seeing here, the changes in Y's. So the idea is, because that's a good fit line, as long as I'm in here where these points are, in between this X coordinate and this X coordinate down here, as long as I'm in that range, predictions should be accurate. But if I leave that range, if I start using the line and plotting points up here and down here, and then like this 321 point we had, that's just assuming that the line continues as we move outside of this range. We don't know if it will. We just, using the line, would assume it does. And we don't know that that's accurate or not. So that's what it's meaning here when you see not meaningful, because we're predicting values that are outside the range of our data. All right, so it's very dangerous to do that, because you're making an assumption that the pattern continues when you have no idea if it does or not. All right, one more time, let's just make sure we got it down. So I'm going to open this up, Control C, Command C if you have a Mac, copy it to my clipboard. All right, delete all this stuff that's in there. All right, paste in my data, click this button right here to give me a line. All right, now I got my line. I can see it's a pretty good fit. And then to predict, so X equals 4.5. I'll just do that one. So X equals 4.5. That's within my data set, so that's my prediction. Right? If it's not in the data set, I think this 13 is going to be way out of the data set. Yeah, it's not even in the window. So let's zoom out a little bit. I can see there's where it would predict it, but that's really far out of the window now. So that would be the one that's not going to be meaningful when I pick that 13. All right, so anyway, that's how we can use Desmos to do these regression plots in 9.2. All right, 9.1 is correlation. Desmos gives me correlation. 9.2 is the regression line. Desmos gives me the regression line when I click that button. Again, let me delete it real quick. So there's what it's giving me. Just click that. And then X equals the numbers to predict values. All right, you can also do Y equals, by the way. So on this data set, X is hours spent studying, Y is a test score. So we're seeing it go up. So the more you study, the higher the test score we would expect. Right? Does it make sense over here to make 112, 113? How many hours would I need to study to make a 62? Well, obviously 62, that's not what I want. That's a X. That's a hour spent studying is X. So what I would need to do here is change this to Y. When I change it to Y, Y is this test score, and you can see now it's a horizontal line that hits. So I need to study about 4.5 hours to get to the 62 range. All right, hopefully you're not shooting for 62. Hopefully you're shooting for 92s. But again, that's not meaningful. That's out of our range of data. Okay, so you can, same as picking X's, your Y's would need to be in the range of the data as well. All right, so if you have any questions about this, feel free to email me. I'll be happy to go into further detail with any of these.